Hi everyone. In today's lesson from Unit 3.2, we'll be taking a look at the properties of parallelograms. First, a parallelogram is defined as a quadrilateral with both pairs of opposite sides parallel. So if we take a look at our diagram, we can identify quadrilateral ABCD as a parallelogram if we know that line segment AB is parallel to line segment DC. And if we know that AD is parallel to BC. Next, we're going to take a look at four theorems related to parallelograms. And our first theorem states if a quadrilateral is a parallelogram, then its opposite sides are congruent. So if a quadrilateral is a parallelogram, so we would have to be given that information, then the opposite sides are congruent. So line segment AB would be congruent to DC. And line segment AD would be congruent to line segment BC. So because it's a parallelogram, we know that those opposite sides are parallel. Now, in addition to that, because we know it's a parallelogram, we can say for sure that the opposite sides are congruent. Our next theorem states if a quadrilateral is a parallelogram, then opposite angles are congruent. So in here, we could say that angle A is congruent to angle C, and angle B would be congruent to angle D. Next, we're going to take a look at how we can use these theorems to set up and solve equations. In our first example, it says that we are to find the value of each variable in the parallelogram. So one of the most important things is that it states right away that this is a parallelogram. Since we're given that it's a parallelogram, that means that opposite sides are congruent, and it also means that opposite angles are congruent. So that's going to let us set up two equations so that we can solve one for x, and then we'll solve the other equation for y. So our first equation would be to say that 16 is equal to 3x plus 4. And again, that's because opposite sides of a parallelogram are congruent. Subtract 4 from both sides of the equation, and we end up with 12 is equal to 3x. Take and divide both sides by 3, and we get x is equal to 4. Okay, in our second equation, we're going to work with those opposite angles. Angle D and angle B are opposite angles of the parallelogram, so they're congruent. So set y minus 60 equal to 56. Take and add 60 to both sides of the equation. And we end up with y is equal to 116. And that's it. Opposite angles of a parallelogram are congruent. Opposite sides of a parallelogram are congruent. Next, we'll take a look at two more theorems involving parallelograms for a total of 4 theorems. In our next one, it says, if a quadrilateral is a parallelogram, then the same side interior angles, or we could call them consecutive interior angles, are supplementary. Be careful. They're not congruent, they're supplementary. Okay, so same side interior angles or consecutive interior angles are supplementary. And that would mean that, say, angle A and angle D, not congruent. They could be, but they're not in every case. But the measure of angle A plus the measure of angle D would equal 180. You could find 4 pairs of angles like this. There are 4 pairs of same side interior angles in here. Another one would be angle D and angle C. So you could say the measure of angle D plus the measure of angle C equals 180. And you can keep going around the figure. For example, measure of angle B plus the measure of angle C equals 180. So same side interior or consecutive interior would be two angles, like one right after the other. All right, in our final theorem, it states if a quadrilateral is a parallelogram, then its diagonals bisect each other. So very simply put, we have the diagonals drawn in this parallelogram. We have diagonal AC and diagonal BD. They're going to bisect each other. So that would mean that line segment AE is congruent to line segment CE, and then line segment DE would be congruent to line segment BE. Okay. Notice that I did not mark all four of those segments congruent. They just bisect each other. It doesn't mean that all four of those smaller segments are congruent, but they are in very particular types of parallelograms. So in example 2, it says find the value of each variable in the parallelogram. So since we know that it's a parallelogram, we know for sure that the diagonals bisect each other, and therefore these segments are congruent to each other. So we can write two equations. The first is 2x plus y equals 36. And the second equation is 4x minus y equals 24. What we have here is a system of equations where we have two equations with two variables. So with a system of equations, you can either solve it by graphing, by elimination, or by substitution. In this case, we're going to use elimination. Notice that we have positive y in one equation, negative y in the other equation. So when we add these two equations together, the y's will be eliminated. 2x plus 4x gives us 6x. Y plus a negative y, they add to 0. And again, they're eliminated. And then on the right-hand side, 36 plus 24 gives us 60. So if 6x is equal to 60, take and divide both sides by 6, and we get x is equal to 10. Now that we know that x is equal to 10, we're going to use that to solve for y. So in the equation, 2x plus y equals 36. If I plug in 10 for x, I now have 2 times 10 plus y equals 36. 2 times 10 is 20, plus y equals 36. So take and subtract 20 from both sides, and we end up with y is equal to 16. So there's the solution to our system of equations. X equals 10, and y is equal to 16. And you can check your answer by making sure that they work, and the values of x and y work in both equations. Okay, finally for today, in our last and third example, it says in parallelogram WXYZ, so let's draw a picture. So here's W, X, Y, and Z. We have to go in the order in which the variables are given to us. It says the measure of angle W is 50 degrees more than the measure of angle X. So if we say that angle X is equal to X degrees, then we can represent the measure of angle W by doing X plus 50. So sketch the parallelogram, find the measure of each interior angle, then label each angle with its measure. So the one thing that we have to remember is that with a parallelogram, consecutive angles are supplementary. So we can say that x plus 50, because those angles, this angle x right here, and angle W are consecutive interior angles. They have to have a sum that's equal to 180 degrees. So we've got 2x plus 50 equals 180, or 2x is equal to 130 when I subtract that 50 degrees from both sides. Take and divide both sides by 2, and we get x is equal to 65. Okay, so this angle up here that was marked with x, we can say that it is 65 degrees. The opposite angle, angle Z, would also be 65. And then to find the measure of angle W, take 65 plus 50. You get 115 degrees. So this angle is 115 degrees, and so is angle Y. You can find angle y a couple of different ways. Opposite angles of a parallelogram are congruent, or consecutive interior angles or consecutive angles of a parallelogram are supplementary. Okay, good luck on the CYU. If you have any questions, please see your teacher.